Good evening, students. We have completed so far isotopes, isobars, isotones, the size of nucleus, mass energy, Einstein mass energy equivalence, mass defect, and binding energy. Today, the binding energy per nucleons. Let's start with this. Per nucleons, it will be denoted by EBM equal to the binding energy divided by, that is, mass number. A is nothing but total number of protons and neutrons present in a nucleus. Graph between potential energy, that is in mega electron volt, radius of the nucleus, that is in factometer of a me. Let's say it is 0. The graph which we will receive, raw 0, where the potential energy is minimum, will be equal to approx 0.8 factometer. The radioactivity radioactivity was a nuclear phenomena in which an unstable nucleus undergoes a decay. This phenomena is given by scientist A. H. Becquerel. Radioactivity was nuclear which an unstable nucleus undergoes a decay. The type of radioactive decay is alpha decay. In alpha decay, the nucleus of helium 2He4 is emitted. We have a beta decay. Beta decay is of two types. First is beta minus decay. Second is beta plus. In these decays, the electrons or positrons are emitted. The third decay is gamma decay. In this, high energy photons are emitted. Now we will study alpha, beta, gamma decay in detail. Alpha decay can be expressed by the following equation: X, A, Z will be emitting a helium nucleus and converting itself into element, let's say Y. Here we are writing again the C. X, Z, A, where A is a mass number and Z is atomic number, emitting a helium nucleus and converting itself into element Y, which is A minus 4. The element is Z minus 2, Y, A minus 4. Example of alpha decay is uranium 92-238 emitting one helium nucleus and decaying into thorium 90-34. For alpha decay, the total mass energy Q will be equal to mx minus my minus mass of helium into c square. Q is also a kinetic energy, net kinetic energy gained in this process. This is also net kinetic energy gained in the process. The Q is greater than 0 for alpha decay So it is a exothermic process. Next we have the second one, beta decay. We have a beta decay of two types. A beta decay is a decay where a nucleus spontaneously emits an electrons or a positron. In beta minus decay, this is a conversion of neutron into proton. We are getting an electron plus a entry neutrino. The example of beta decay would be phosphorus in 22 that will be converted into sulfur, plus we are getting electron and entry neutrino. The next is beta plus decay. The basic nuclear process under beta decay is proton converting into a neutron, plus we are getting a positron and the neutrino. The example of this process is Na converting into Ne, and we are getting a positron plus neutrino. This is beta decay. Next we have gamma decay. See, like an electron atom, nucleus is also having a discrete energy levels. So when a nucleus is in an excited state and it is spontaneously decaying to its ground state, the lower energy level, a photon will be emitted, and the energy of that photon will be equal to the difference in the two energy level of the nucleus. Example of gamma decay is cobalt. Cobalt is going through first beta minus decay and subsequently emitting or going through two gamma decays. So first it is going through a beta minus decay, then two subsequent gamma decay and converting itself into nickel. It's 2860. The energy of photon will be equal to the energy of two different energy level of the nucleus. So first we are getting 1.17 mega electron volts and then 1.33 mega electron volts. It is the excitation of the nucleus. This is gamma decay. Next class we will study average life, half life and law of radioactive decay.